All right, hello everybody, and welcome back to another installment of the Dam Control Assistant Senior Enlisted Curriculum. I'm Lieutenant Timothy Mueller, and for this lesson, Chapter 6, Lesson 1, we'll be going over trim definitions and other aspects of the longitudinal perspective of a ship. Now, so far in talking about ship stability, we've only really talked about transverse stability. Transverse being we're looking straight on the ship, so we have a port and starboard side. Now, we're going to flip that perspective from front on, or stern on, to the side. So we're going from transverse, so our diagrams typically look like this, to longitudinal. So in this chapter, my diagrams are going to look something like this. So this is going to be a ship, this is going to be the bow, the pointy end, and this is going to be the stern, the flat end. Now there's a couple new terms that we have to identify here in this part of the video. I'm going to draw them on this large diagram here on the right of the screen. Now first off, we have a few that are all very mixed together. We have forward perpendicular, aft perpendicular, middle perpendicular, and length between perpendiculars. And they are just exactly what they sound like. We know that a ship is made up of frames, and these frames run transversely, and they are pretty much perpendicular to the waterline of the ship. So the forward perpendicular is going to be right where the ship meets the design waterline. Design waterline being another thing that we're going to define later. If we take this blue line as the naval architect's design waterline, the forward perpendicular would be right here. Right at this point there. All of our frame numbers increase as we go aft. And then if we go forward, so towards the bull nose of the ship, then we would have Alpha, Bravo, Charlie, so on and so forth. Aft perpendicular is the same thing, but on the stern. So right here, typically you might see some transoms that go out, but usually they'll just be straight up and down. So here, we're going to have our aft perpendicular. Middle perpendicular is the frame that's right in the middle of them. So if this was 0 and this was, say, 100, the middle perpendicular would be 50. The middle perpendicular is going to be right around here. And the symbol for the middle perpendicular looks kind of like a tennis ball. It is something like, just like that. So if you ever see this symbol in future lessons, this means middle perpendicular. Then the length between the perpendiculars is just the distance from the forward perpendicular to the aft perpendicular. It's not necessarily the overall length of the ship. So if we had this frame being 0 and this one being 100, our LBP, length between perpendiculars, would be 100 feet. Now, next up is a very, very crucial term when it comes to longitudinal stability, and that's LCF, or longitudinal center of flotation. By definition, the longitudinal center of flotation, in what we're going to be using it for, is the point where if we shift weight on a ship forward or aft, then there would be no change in draft perfectly at the LCF, that longitudinal center of flotation. Everything else, if we move, let's say we move weight forward, we would expect the forward part of the ship to go deeper and then our aft part to come up. If we shift weight aft, we would expect the aft part of the boat to start sinking deeper and the forward part of the boat to become shallower. That LCF is going to be that pivot point if we think of the boat as a seesaw. So the LCF on this type of a diagram, we're going to show as just a point. And it only matters how far it is aft of the middle perpendicular. For monohull ships like this, the LCF is typically aft of the middle perpendicular. For some special hull shapes, it'll be either at the middle perpendicular or forward of the perpendicular. But for everything that we deal with here in DCASE, surface warfare ships typically have an LCF aft of the middle perpendicular. So here is the LCF. Now, you've seen this line right underneath of this diagram. When I explain trim problems and how to calculate changes in draft, I'm going to use a diagram that looks just like this. It's going to be a straight line with a couple annotations on it. This line just represents this ship in general. So if we have an aft perpendicular being the very end of it, forward perpendicular being the very forward part, Middle perpendicular goes right in the middle. The LCF, I'm going to draw as a little pivot point. Because the LCF, if we assume it doesn't change, and for small changes, or actually for pretty appreciable changes in the displacement, the LCF doesn't change very rapidly. That LCF is going to stay the same. So when we add weight, it's going to sink parallel, and then there's going to be some shifting, and it's only going to be right at that LCF where our draft does not change. That's why I draw it like a pivot point. All right, now next up is design waterline, and I kind of jumped the gun by drawing it already in order to define aft and forward perpendicular, but it is a point that is more of a boundary condition for the naval architect when they make all their calculations when it comes to moment to trim 1 inch and everything else that goes into the longitudinal aspect of the ship. It also plays into the transverse as well, because we had seen design waterlines on our figures in previous chapters, but with longitudinal, it's very crucial that we know right where our design waterline is. Next up, we have drag. Now, when we see this diagram here, I've drawn this boat perfectly straight. So the draft aft and the draft forward are exactly the same. Drag is a designed difference in drafts. This is typically used by the naval architect to increase the efficiency of the propulsion plant. So it lets the propellers dig into deeper and denser water. So if we say that a ship has 1 foot of drag, then that means, 1 foot of drag by the stern or by the bow. It means that if we have by the stern, it means that the ship is designed to have the stern 1 foot deeper than the bow. So for example, we would have a forward draft of 10 feet and we had 1 foot of drag, we would have 10 feet forward and 11 feet by the stern. If we had anything different than that, so if we had drafts that didn't match up to 1 foot difference by the stern, so the stern is deeper, that excess is going to be trim. Trim is the difference in drafts in excess of drag. And this BB means by the bow. It's also called by the head, or BS, by the stern. Now with trim, let's say we have the forward over on this side and the stern over on my right side, your left side. Now if we have trim by the bow, that means that the bow is sinking lower and lower. If we have trim by the stern, that means that the stern is sinking. Whenever we say by the head or by the bow and by the stern, that means that whatever we just referenced is deeper in that perspective. Drag by the stern means it's designed to be deeper at the stern than it is at the forward. And then trim just changes that. So it's possible to have 1 foot of drag by the stern and then 6 inches of trim by the bow. That would mean 1 foot of drag by the stern and then 6 inches by the bow. It would look something like that in the overall movement of the ship. Now, just a second ago, I was talking about drafts being 10 feet and 11 feet and 12 feet and whatnot. How do you know how much ship you have underneath of your waterline? That's through draft marks. If you've ever seen a boat out on the harbor or ocean or anything like that, you've probably seen these or something very similar on the side of the boat, both port and starboard, forward, maybe in the middle or somewhere near the middle, and then aft. These tell you just how much ship you have underneath of the waterline at that exact time. Now, so here we have a 10 or a 10, and then we have a 1 up here. These numbers are 6 inches tall, and they are spaced 6 inches. So we have 6 inches here, and then 6 inches here. We just read the waterline, and that'll tell us what our draft is, and the draft being how much ship we have underneath of the waterline. The bottom of the number right here would be 11. And then up to the very top of the number would be 11 foot, 6 inches. So if we have waterline here, that would be 10 feet. Waterline here would be 10 feet, 3 inches because it's halfway up that 6 inch lettering or numbering. Right here would be 10 feet 9 inches. Right here would be 10 feet 12 inches or just 11 feet. And that corresponds with the very bottom of that 1. Then up here would be a 2, 3, and so on and so forth. And the same system carries all the way up to the very top letter. Now, these aren't the only draft marks that you're going to see. This is typically found in ships that were constructed in countries that use English units. You can also have metric, so you would see like 8, 0, 2, 4, 6, 8, and then 9, or 90. That would mean 8.0 meters, and then 8.2 meters, 0.4 meters, 0.6, so on and so forth. And you can also see Roman numerals. There's several different drafts that can be measured on a ship. You have navigational drafts, calculative drafts, critical drafts, so on and so forth. There's also different marks that you might find on the side of the ship. Right here is a very important one for ship stability. It's called a limiting draft mark. We'll learn about that when we talk about floatable length, and also for taking on damage. Down here is something called a Plimsoll Mark. You'll find this very, very frequently on cargo ships. I'm not going to go into it because you don't need it for decase. However, if you're interested, you can look it up on Wikipedia or something else, and you can find out what all these lines mean and what this load line disc is. So now in this chapter, we're going to go over a lot of stability problems when it comes to trimming a vessel, how a ship moves longitudinally when we add weight, remove weight, and shift weight. Remember, the LCF, that all-important pivot point on a ship, is typically going to be aft of this middle perpendicular. So when we see something like LCF equals 10, that means that the LCF is 10 feet aft of the middle perpendicular. Now we're going to go on into some problems, and there's going to be a little bit of geometry that we need in order to solve these trim problems, but that's going to be for the next video and videos after that. Until then, I'm Lieutenant Timothy Mueller, and I hope you have a great day.